webinars on web architecture for the Internet of Things. This multi-series, multi-sessions sessions on covering entire the world of Internet of Things. And today in particular, we will be covering about web architecture for Internet of Things. So in the previous session, actually, we covered about the introduction to IoT, and this particular session we will be covering Internet of Things, and the following sessions will be covering about security and other things. Let me just recall what we did in the previous session. In the previous session, we covered what is IoT. It's a new world order where actually things are getting connected to the Internet. And IoT connects objects and make them talk to each other. For the first time, we are establishing a connection between the devices through an Internet so that they can talk to each other and share information among themselves. The current existing Internet actually allows people to share, allows machines and devices to connect to that. And once this connect, those people collect information, exchange information, talk to each other, and because of this they can make their own decisions. And this way they become a kind of a smart devices which will create an environment where actually we can depend on them for conducting certain works. And in today's session I will be covering web architecture for an Internet of Things. See, architecture is a very fundamental idea. Anything that we have to create in this world which is useful in many people must have an architectural approach for that. So today's agenda will cover a need for an architecture, why do we need architecture, and general examples and illustrations, approach towards building an architecture. Suppose we decide to build an architecture, what are the ways we can follow so that we can develop them. And normally when we build anything, we have some challenges. So even IoT architecture is not an exception. That we will cover. And finally, we will use web as the basis for building an architecture. This one. Okay. Let me start with the concept of an architecture. See, the concept of architecture is fundamental to any human-inspired creation. Maybe God, when He created this universe, might not have used architecture, but any human-inspired activity or any human-made structure in this world will have an architecture. For example, Taj Mahal, which is about 500 years old, or even look at this pyramid, which is about a couple of thousands of years. Element in modern constructions like Bhatranangal Dam or metros in Bangalore or Delhi or Calcutta city, they also have a kind of an architecture which is creating something new. When you consider this, actually architecture is everywhere. You cannot just imagine this modern world being built into that. See, for example, just after the independence in 1947, as you know, the Punjab state got partition between Pakistan and India. And when they wanted to create, when they wanted to make a capital city in Punjab, they didn't have a big city enough to make that one. So the then Indian government decided that actually we will build a new town called Chandigarh. Okay, and this was built from the scratch. Unlike other states which already had some cities where a capital was established, Chandigarh was actually newly built from scratch actually. And that process of actually identifying a space completely was a city. So, and secondly, just look at this example. See, computer and other games, but even game engine, game creation is actually needs an architecture. So, something of Google. So it gives answer to everybody who puts a keyword. It allows you to develop different games depending on your choice, your parameters. Even this actually this is the architecture which we have to use in day-to-day life. And coming to the mechanical engineering, see, for example, you look at a vehicle here. So now, so the core architecture of this NQ approach. So the engineer brand actually uses architecture which this shows teaching of one where medical college is attached to a hospital. But actually, in order to build the electrical appliances, they have an architecture here. It is the top level function of anything, whether it is a city or an engine. And we all use computers, sir. Companies like Intel use they do actually develop these processors, and they have an architecture of their own. So what it means is, no matter what you create, if it has to be useful for a large number of people, architecture is going to be the fundamental. It's the time to define what is architecture. Architecture is the process of conceptualizing through constructing something. First thing that comes is actually architecture. Even in the construction of a civil building, architecture will come first, then engineers, and then the construction will come. And today you must have heard the terms like solution architect in a software company, or a cloud architect in a cloud company, or even because of this big data. The point is this: architecture is the beginning point of anything that worthfully created in this world. Take you through a particular case where actually how difficult an architecture process is all about. So this example will tell the challenge within an architecture. Develop a transportation system in India where it is possible to book an item for a parcel in one corner of the country and deliver it in another corner of the country next morning. Is it possible today? Today it is not possible. For example, no, this is how India looks. East to west it is 2,500 kilometers, and north to south it is 3,500 kilometers. Suppose I want to book an item, say in Kashmir, and to be delivered next morning in actually say Kanyakumari, or suppose I want to book an item from West Bengal and should be reached Gujarat the following day. It is not possible. Why? We do not have a transportation system like that. So designing such a transportation system actually heavily depends on architecture, because it's a very fundamental and intellectually challenging job. The point is this: architecture is not a straightforward job. It is the first level of creation that anybody has to do if you want to build a system which is useful for a long time and a large number of people. See, look at this example. This actually is an architectural challenge which says system to transport item overnight across India. Look at this. Suppose, we actually have been used to buying certain things from companies like Amazon.in or Flipmart. And whenever you book an order book an item online, it takes normally 2 or 3 days. Why does it take so much? It is not because Amazon want to delay the sending of an item, or they have stock kind of thing. They don't have a courier companies which can deliver an item across the nation in a day's time. Okay, so that is a challenge. So now it will show you that, see, whenever you want to design something which is challenging, it is not that easy. But it is not all the time. Some people have solved this problem very well. For example, I'll show you a successful example of an architectural design. In the United States, there is a company called FedEx. FedEx is actually Federal Express. It's a courier company. And this company is known for actually delivering your items overnight. So America is actually as big as India is, in fact, geographically much bigger. But what they have done is actually, if you look at the map here, see, there are some arrow marks coming to the center of America here. So what this Federal Express company has done is actually, they have built one base in the center of country, and they will actually collect all the items across America until the evening that day. And a special plane will actually start from that location and come back to the center of the the place, and take back the item from there. So this is a kind of an architectural design in 1970s and 80s. You will see the picture here actually. Now thousands of planes come to the center of America carrying all the items which have been booked for the parcel the previous day, and they collect the items and go back. What it means is a flight will come from New York carrying all the items which have been booked from New York to the other parts of America, and actually unload them in this central part and take back all the items which have been booked for New York the following day. How is it possible? Because the founder of this organization actually personally and as an organization designed, architected this so that any item can be collected any corner of America and can be delivered the following morning. Okay, so the whole point is to tell you that architecture is an important thing, and no matter which area of life you have been talking about, whether it's parceling an item from corner to corner in India or developing a game engine, architecture is very important. So any question at this point of time? Sridhar?
No, sir.
Okay, I'll proceed. Okay. So now that we know the importance of this, we will move on to an architecture design for Internet of Things. So whenever you want to define or design an architecture, there are 3 different things which must be taken care of. One is the element, things that are involved in this, and how do they interact, and then finally behavior. Say for example, if you are developing an architecture for developing a transportation system in India, then elements are vehicles and roads. Okay, and what are the interaction? Traveling on them is actually the interaction. What is the behavior? Behavior you expect because you don't want very crowded, very traffic intense roads. You want, no traffic jams kind of a thing. So in any architecture, there are elements which will interact and produce a behavior, and it is this behavior which is actually a result of designing any particular architecture. So for the world that we have been developing an architecture for IoT, the internet had created cyber world. So when the internet became a reality, it created a new world called cyber world. And that connected computers. It's called machine-to-machine communication. And behind these machines, we normally expect a people. For example, if I send an email using my cell, my cell or my computer, it is part of the internet. So there's a machine-to-machine connection. My computer will be connecting to your computer, and I'm sending an email. But now we would like to extend this connection to other things in the world. For example, my fridge, my wallet, and all. Hence, this system is called cyber-physical system. Cyber because it is the internet. Physical because it is actually connecting to physical devices like a light or a car and so on. So actually the IoT extends the existing internet to include the physical world of this or physical devices of this world. So within this IoT we have different components. We have architectures, we have operating platforms, generic enablers, embedded systems, network technologies, semantic interoperability. Let me explain. Architecture, I told you, a kind of a platform or infrastructure that we will build so that IoT can happen. That means a device in my place in Harvard can talk to a device, say in Surat, using an internet. That's called architecture. Operating platforms, because there are, today we know in computers we have different operating systems. So similarly on IoT we'll have a system, platforms where actually these devices will be placed, they will be made operational, and they will be made to contact to others. Generic enablers like networks or sensors, actuators. Embedded systems, many times in these systems to make smart, we have to build some kind of a processing capability into that. These processing capabilities are embedded into that. For example, we have embedded systems in electronics. Okay. Network technologies which will connect a device, say in a place to another place. And semantic interoperability, that is when a device talks to another device, they must understand each other. So whenever you talk to somebody or whenever you use a language, there are two things that you should notice. One is the syntax, that is how do you write, and the semantics, that is what is the meaning of that writing. So now that we are making devices to talk to each other, they must be capable of understanding each other's instruction. That is called semantic. And finally the security, because we don't want to share information with the people whom we don't intend to do that. So now let me explain why do we need a new architecture. See, IoT is a phenomenon that needs to happen on a platform, like internet happens on the networks. Similarly, telephone devices, communication happens on telephone networks. Okay. So this is required. Transportation happens on roads, railways, and airports. So transportation is a phenomenon. Where does it happen? It happens on roads, railways, and airports. Similarly, where does communication happen? It happens on telephone, mobile networks, and so on and so forth. So now you look at the bottom line. There are elements, interactions, and behavior. What are the elements? In transportation, it is the roads, railways, vehicles. These are the elements. What is the interaction? A person will travel on a vehicle. Airport will actually receive planes. Railways will take passengers. So these are the interaction. What is the behavior? Behavior is actually the traffic jams kind of a thing, or a kind of any activity. Similarly, communication. If you want to talk to another person, that we are using telephones or mobile networks. So what are the elements? Here the mobile handset is a device, is an element. A user is an element. Network is an element. So any activity that wants to be happening on a global level needs an architecture. Now we will look at certain new realities which will force us to create an architecture for IoT. The first thing is, we today are very lucky to have cloud computing in big data, because they will make everyone to access additional resources. For example, today we have a lot of storage space available on cloud computing like Google, and we also have, it is possible to have like processing power. So this actually enables us to observe things, learn things, decide, act, and communicate with other subjects. What it means is, suppose I can create a document today and share with others. Why is it possible? Because cloud computing things will give you free. So the same capabilities can be extended to other objects. For example, it is possible that I have a device which needs to store a lot of data. I can use cloud computing to enable that. Similarly, I have a lot of devices which have collected a lot of data and I want them to process. Big data will help us. So cloud computing and big data are enabling people to do more and more things. So what is the point? Get data and insights from different places without being there. What it actually means is, using a cloud computing network and using a big data, it is possible for me to put some kind of a sensors across my college campus and collect data, what is happening where. For example, I can put cameras across the campus, I can put sensors across the campus and look at the temperature variation. So this is possible because we have a network and also processing capacity. Secondly, when you are talking about the devices which can be connected to network, they are of different sizes. It could be as small as a nano device or it could be as big as a bulldozer. Okay, there is no end. And on the left side, you actually M2M communication. That means two machines can communicate. Okay, so all the smart devices, look at that, your cell, your computer, your fridge, your home, everything can become a kind of a cognitive and a smarter device. That means they are capable of processing data, they are capable of taking decisions, and all this is possible. And this is the first reason. That means it is making everybody, cloud computing and big data, making everybody to process more data, collect more data, absorb more data, learn more. Hence, we need an architecture to see that this happens. Secondly, the major IT players like Google, Apple, and other companies also taking significant decisions related to IoT. For example, Amazon has a platform called Amazon Kinesis, which will help you to use IoT implementation. Similarly, Microsoft has Azure Event Hubs, which will help you to develop and design and actually deploy IoT applications. Even our very famous Google search engine, in addition to search engine, there's something called Google Cloud Pub Sub, which is actually a messaging system which will help you to connect two devices or more. And telecom operators like telephone, like BSN and all, they are also talking about many things where actually a device will talk to another device. For example, phone talking to a computer, computer talking to a TV, TV connecting another computer talking to a particular vehicle. More than that, even this IoT can extend their services even to a human people. For example, manufacturers of devices such as wearable devices, for example, a ring or an implant, and also can actually offering full mobility and anticipate a new business segment and wider adoption. Look at this picture. See, for example, there can be a device on on a person's shoulder which will measure his blood pressure. Right side, you see that. Similarly, there can be one which actually measures his body weight. So on the left side, actually, you see there may be a device which is put on him, a wearable like earring or something like watch like that, which will monitor what is the sleeping pattern of this person. So that means these wearable devices can do many things in the health industry. Thirdly, even computer companies and service providers are trying to integrate the IoT devices into existing systems. Now in our college or any institution, we have computer systems, IT systems and all. Now it is possible that whenever a new device comes to the system which is smart enough, it is possible to be made part of that one. For example, a Bluetooth technology can connect two devices. Similarly, this IoT will take this further up and connects every device into network. So the point what I'm telling is actually now certain things are happening which need a platform. So for example, big data and cloud computing enable us to collect a lot of data. Major companies are starting to offer some IoT services. So IoT has a very simple definition. See, it's a dynamic global network infrastructure. So it's an infrastructure, okay, with self-configuring capabilities. These devices which we connect to them, they are self-configuring. That means if there's a variation in the temperature, they actually adjust their functioning based on the standard and interoperable communication protocols. So the communication protocols are actually interoperable. So in the internet, what happens is it's a computer will talk to a computer, a cell which talk to a cell. Whereas in IoT, a device of variety of devices will talk to each other, where physical and virtual world come together. In internet, it is only cyber world, whereas in IoT, it is a physical world, which have identities, physical attributes, and virtual personalities. Identities, for example, say my fridge may have a unique number which can be identified by the manufacturer. Similarly, physical attributes, for example, sensor have a size, they have a capacity, and all those things. And virtual personalities. See, there is something called Second Life kind of a thing, where actually you have a virtual real personality. That means in a real world you are something, but in this virtual we have a different name and identity. And use intelligent interfaces. That means it is not like we connecting a mouse to a machine. Whereas they are intelligent means when they connect it, they talk to each other and share information and make certain which is required, and they're seamlessly integrated. These IoT devices can be connected to other devices or other systems without any problem, and joined into the information network. Today, much of the information on the internet is generated by people, whereas in IoT, that kind of information is generated by the devices. And what does actually happen on IoT? These are the functional things. So when you have an IoT, left side you see there is a sensing. The first thing that happens in a device, in IoT system is a device will sense. That means it will find out what is the temperature in the surrounding, what is the humidity in that. And suppose it's on a patient or on a medical care, then it will find what is the blood pressure of a student. Then connectivity nodes, and once this collected information can be sent to a connectivity node. For example, whatever is measured on a patient body can be sent to a doctor, or whatever the humidity measured can be sent into a weather forecasting organization. And layers of embedded processing. So this processing can be happening at the point where it is collected, or it can be gathered and connected elsewhere. And then that is connected to elsewhere, I mean to a remote control kind of a thing. And then will be applications and action. What it actually means is, suppose on the left side we have a sensing. So a particular sensor or a variable on a particular patient will look at his monitor his blood pressure and connect it to a doctor, and accordingly doctor or a system in the hospital will take some action that you see on the right side. Similarly, suppose somebody is measuring the humidity in an in a field, then depending on the level of humidity, a farmer might decide whether go for watering today or not. So when IoT comes into implementation, there are many applications. There could be smart homes, smart cities, smart lighting. What it actually by smart means? See, today if you see in many of the towns, there are street lights. Many a times, often we see that they are actually still on even in the 8 o'clock in the morning. Why does it happen? Because today manually somebody has to off the light, and if they forget, this will continue. But if you have an IoT system where actually somebody, the IoT will sense it that this is 6 o'clock in the morning, then it automatically off. That kind of a thing called smart lighting. And as you know that the new Indian government actually is planning to develop some 30 smart cities in India. So the concept of IoT is very simple. It would like to connect the world much deeply and more widely, and by doing this actually it has to make everything addressable, everything accessible, and everything actionable. Okay. So the whole summary is that we have a new challenge on our hand, a new opportunity at hand, where actually the technologies are helping people to collect and do more work. Similarly, devices are there which can talk to each other. So now, to happen seamlessly, to ensure that this happens smoothly, we have to develop an architecture. Any question at this point of time, Sridhar?
Not yet, sir.
Sridhar, any question, sir?
No, sir.
Okay, I'll proceed.
Yes, sir.
So when we want to develop an architecture, there are different approaches we'll take. For example, suppose somebody decides that we have to develop a transportation system in India. Then somebody say like, let us build roads. So that's one approach. Somebody says, no, we will build only airports. Okay, there's another approach. Somebody says, no, we will build only railway lines. So the one problem is one, that means building a transportation network. There are three different approaches. One is railway, one is road, one is airplane. But if you look at countries like Italy and all, there are approaches where actually they have waterways. They don't have roads, they have actually waterways. So approach is a particular way that you take to build an infrastructure or an architecture. So overall, whenever you build an architecture, the initial step that you take will decide the fate of that particular approach. Okay. Most of the work related to IoT architecture has been from the wireless sensor network. In fact, IoT revolution started in wireless network. They had actually looked at the technology and all. So that is actually the beginning point. But now, if you want, if you limit your approach only to the wireless network and all, then you would miss lot many things. For example, wireless devices cannot be connected to many of the things which are like programming and all, programming devices, applications and programs. So now you should take a wider approach. So the Sir, can I continue?
Yes, sir.
Okay. So the point we are talking is actually whenever we have to develop an architecture, there are different approaches. So for example, as I told you earlier, suppose you want to build a net transportation system, you have three approaches. One, you can build roads, or you can build railways or airports. Similarly, when you want to develop an architecture for the IoT, then there are different approaches. For example, much of the IoT actually started in wireless networks because they are the people who put sensors across and started doing that. So shall we go based on that one? That's not a correct approach because that would limit the strength of our system only to the wireless enabled devices. So another approach which people suggest is actually to make is to use the web as the basis, so that web today is a global network which many people are using. So is it possible that I make web as a basis for my network IoT, then I can reach more people? And third approach is, say, some people say you can use cloud based approach because cloud actually gives you a lot many resources that actually you can use it. Okay, but there are many applications for which the cloud is not good. So the whole summary is that we are just trying to explore different approaches which can be used to build an IoT infrastructure. So what are the necessary things that I need when developing a IoT? I need sensing and data collection capability, because any device to be intelligent, it must collect the data. To collect the data, it must sense the environment. For example, if the thermostat, it should say that there is a variation in temperature. If there is another device, it should say there is a change in humidity. If there is a variable medical implant, device on a particular patient, you should be able to find variation is blood pressure or a sugar content. Okay, that's the first thing. And once this is done, there should be local embedded processing. That means the moment the data comes to that machine, then actually it should be able to process it. Should I hold the data or send it to another agency? And these all activities, they happen frequently. For example, you have to continuously keep collecting data about the environment. You have to keep collecting this data about patient 24/7. For that, you cannot manually do it. Actually, that must be automated. So that means you also need a software. And finally, you also use a remote network. For example, if you are collecting weather-related data here, then it should be sent to a central location where you have to predict weather for the India tomorrow or a particular town. Or if you are collecting data about a patient, then that has to go to a doctor which is in the hospital, which is far away. So essentially, there must be sensing data and local embedded for processing and to communicate that. So these are the essential requirements of an IoT. So I want to develop an architecture for this. But what are the challenges? The application potential of IoT today is currently fragmented by fragmentation due to a plethora of communication technology. That means everybody is using different standards. For example, there is an IoT kind of thing in every modern car today, but every manufacturer of car, whether it is an Indian company or American company, they use their own standards, which are not interoperable. That means a communication device which sitting at my college cannot talk to my car IoT system for a simple reason they use a different standards. This was a problem even before. For example, before the internet came into existence, we had this problem. An operating system like Unix cannot talk to an operating system like Windows because they are not operable. So that's the first barrier. So if I want to develop an IoT architecture, I must have a standard one which actually compares with others. So what is the solution? Open standards will be critical for enabling exponential growth of IoT. And in the 1990s, internet was a very small affair because only research people used to use. But once actually it was given a kind of language called HTML and other things, people started using a lot. So that was because HTML is an open standard. Anybody can write a program and publish. So something similar we want to do it in IoT. We want to develop something which is open in nature. And the solution is very simple. We are going to use web protocols and scripting language for implementing services, because IoT devices generate data and that data can be used to build services. So one of the best way to start is to use web protocol. And when you want to communicate between 2 or 3 applications in web today, we use what is known as API, that is Application Programming Interface. Now we are trying to explore, is it possible to extend this API to device talking? That means when a machine is talking to another machine, can it use this API? So that's the second thing. And we are also using this HTTP and other protocols like SOAP protocol to establish. The point is this: we are trying to find out a mechanism where actually I can build an architecture. One of the challenges that I face is 2 devices are not compatible because they are using 2 different standards. So since web is a very popular one, can I use web as a basis? And what's the concept? See, until 1990s, internet was actually communication between two machines and all, because it was using a network layer. But when somebody started using HTML and a browser, it became an open standard, so more and more people can use. That means I upgraded my internet to web by adding an additional a presentation layer, right? So, upon an application layer. Similarly, is it possible to use an existing internet or web and add one more application layer so that these devices can be programmed using that application layer? And that is the approach that we are taking. So with this, actually, we come to a point where actually web is used as a basis. So rather than inventing completely a new standard, so we don't want to develop an entirely new structure or a new architecture for IoT. What we are going to do is we are using the existing web. So what we are doing is we know that there are some programming standards like REST, HTTP, JSON and all. So this we will be using so that we can develop an architecture based on which we can develop IoT application. So today we have an internet. So when people started developing the internet, they didn't develop their own network. Actually, they used the existing telephones. Similarly, for tomorrow's IoT architecture implementation, we are using existing web as a basis. So when I develop that, this is how it looks. Now there are devices at the bottom, and there are communication protocols at the middle. There's HTTP, you can see, and there are services which will aggregate them, and there are portals at the top level. So IoT reference architecture will talk about devices which will be connected, and the protocols which will be used to communicate, and finally the aggregation point. The point where I'm trying to relay is I'm using web as the basis to develop an architecture for the IoT activities. So when I do this, you look at this. There is a physical world at the bottom, and there is a sensory network. So that means in my college, I can install some sensors, about 500 sensors across my campus, and keep collecting data about temperature. So that is the second level. And this actually goes to a college network, Wi-Fi, and that in turn goes to application gateway at the top point, and it will be used. So depending on whether a medical application using data collection from thousands of patients across India, or somebody using that data to collect humidity information in different places, this would happen. So interaction time. Any questions, Sridhar? Any question?
What are the limitations of cloud for IoT implementations?
What are the
limitations of cloud for IoT implementation?
That's what actually, see, what happens is cloud is, Hi, I have got it. See, the question is that what are the limitations of cloud-based services in the context of IoT applications, right? Okay. So the thing is like, see, cloud is a very global system. Okay, that means, you know, companies like Google, they have data centers across the continent and all. So there are many these services are good. Suppose your application is also global in nature. For example, if thousands of people are using your service across the globe, then it makes sense to use a cloud-based service. But there are applications which are very local in nature. For example, if I am collecting information about the temperature in my campus or humidity in my field, there is no point that data going to cloud and coming back to me. So that means because that would be used only in my field. So in such cases, actually, we don't recommend you to use cloud-based services because it's a limitation, because you have to add additional traveling from data from your place to cloud center and come back. And this will create what is known as a latency problem. That means there is a delay in which you're sending the data and collecting the data. So for that, actually, we have services called network edge services, and this is called fog computing. So what fog computing does is actually, it will create some resources at the edge of your network. For example, at the end of my campus, I will have a source which acts as a cloud, but it is not stored in the cloud. So the first answer to your question is actually cloud-based have applications, have a limitation in applications which are totally local in nature. So if the application is completely, for example, if you have an examination system in your college and it is only limited to your college, and there is no point in using that data, that is stored in the cloud. It is better to store it in your location. Any other questions, sir?
No, sir.
Okay, I'll proceed.
Yes, sir.
So now I'll come to Web of Things. Web of Things is actually an architecture built for IoT. What is this? Web architecture is a term used to describe the approaches, I told you what are the approaches, software architectural style and programming patterns that allow real world objects to be part of the World Wide Web. So I told you the objective is to connect things. So how do I connect? I have developed some approaches, some are software architectural types and other programming whose intention is to connect this real world. And this is called web architecture for IoT because it connects this. And it's also called web of things because it is moving from Internet of Things to a next level where things can talk to each other and they can be programmed. So what does this include? Web of things usually consists of things of the physical objects. Unlike a computer connecting to the Internet, we are connecting physical things. This could include like NFC, QR codes or tagged objects, barcodes, image recognition, wireless sensor networks, machines, vehicles, consumer electronics, all these are included. So when I create web of things, I am using the Internet to extend so that I can connect things, and when I connect those things, these are the things which are included in that, and they are all physical in nature. So web of things is a set of best practices. We have learned many lessons from the web. So now we have to use those lessons, and these lessons are called best practices. So when I'm developing an approach or an architecture, I have decided to have 4 layers. So when people develop these network layers, there is something called OSI layers, which has 7, starting from the physical layer to presentation layer, between that network layer, communication layer, and so on and so forth. Similarly, web of things will have 4 layers, and that I will be covering now. Okay, and you look at this web of things architecture. There are 4 layers. So at the bottom level, actually you have a accessibility layer where actually you access resources. Then findability. See, for example, what it means is, now how do you find things on the Internet today? Today you actually use Google search engine. Similarly, how does Google will find out? Because all those things which have a URL can be connected using the search engine. Similarly, we have to develop a mechanism where each item has an address, and that address can be found out. So this is done using an IPv6 address. Sharing is a process where actually 2 devices which are found each other can communicate by sending some information. Composition is a process where actually the data which is coming from 2 or more devices is actually composed at a location for a better meaning and better management. And applications are those which are actually built using that. For example, today we have a Google map coming, and you can build an application which is useful for your town. How are you building it? You are using Google map as the best data. Similarly, in IoT, you can use many services. So on the left side, actually you see many applications on the right side. So web of things will have these 4 layers. The top one is called accessibility layer, then findability layer, sharing layer, and composition layer. The accessibility layer deals with the access of things to the Internet. That means if I have a sensor in my SDMCT, and suppose you have one in Hyderabad, this accessibility layer will connect that device to the Internet. That means a device in my town, Dharwad, can connect to your device, can access your device in Hyderabad, because the Internet will help you do that. Since it helps the accessing a device elsewhere, it's called accessibility layer. And it ensures that things expose their services via web API. That means this device which I have at my home, like a sensor or a wearable device, is capable of actually developing some applications on API and made it accessible to others. And this is a core layer of web of things architecture, where it makes web accessible. That means from web I can connect to you. For example, today I can connect my machine to your machine because it works on Internet and there is a protocol. Similarly, I want to do that. Accessibility are core patterns. They're actually first, this will convert into a RESTful API. RESTful API is one of the fundamental API used in the cloud computing, which actually it makes things to be able to find out and communicate with them. REST is an architectural style that root of the programming language. That means REST protocol is actually a standard which helps user to write a program so that I can access the device. So as a result, if things offer RESTful API or HTTP protocol, they get an URL. So giving an address, I told you there are 3 things in IoT. We have to make things addressable. That means they must have a unique number or address. And once they have address, I can give an URL. So accessibility layer actually does this job. What it means is it will connect a device and use an address to that one. And this address can be used for many purposes. Either you want to say hello to that device, you can use the same URL, or you want to talk to that, you can use the same device. One of the limitations of existing internet which actually cannot be used in IoT is this. See, today's internet is actually a request response. What it actually means is, suppose you go to a Google search engine and you give a search word. The moment you search and get the result, Google will forget you. That means you request for a search and it responded. Once the response is given, actually it stops. But that kind of a communication system will not be good in sensor devices or IoT. So they need an event driven. For example, if there is a change in the temperature, the device itself will not make any request, right? And there is no response will coming because nobody has made a request. So now we are converting, we are changing this approach. In case of an IoT, we are not actually limiting our to request and response. We are doing it to event driven. That means there is any senses, anything that is made, change or many noticed will actually trigger an event, which in turn can be captured. Okay, to overcome this, actually a new language called HTML5 uses what is called WebSockets. Can be used as a native layer through translation brokers. What it means is, if there is a variation in a variable in a patient which is collected, patients like heartbeat or a temperature or sugar, this collected information can be collected by WebSocket programming and it can be transmitted to a doctor. So once I made it accessible, then the second question that I do, it should be findable. That is, how do I know that how many things are there on the internet which are IoT enabled? So to do that, I need some mechanism to find out. So if you have studied this service-oriented architecture, this is what actually happens. So anywhere when somebody wants to use a service, he has to find it. It is something like in a telephone directory, you have this yellow pages. So what is the purpose of yellow pages? See, that means if you are new to a particular town and if you want to use a particular service, instead of asking other people, you can always use this yellow pages, which will tell you which service is available. For example, if you want to use a plumber service or if you want to visit a doctor, these yellow pages will list the number of doctors, their phone numbers and all. Similarly, on internet, on this IoT, there is a kind of a directory which will help you to find that one. So once you find it out and locate those things, that means you, with the help of a phone number, you find out a doctor and you collect address from him, you go to a shop. Similarly, with the help of a yellow pages, you will find the phone number of a plumber and get his address and go. Similarly, in this one, you can actually find the location of a service and start using them. So this is how it looks. Findability will help you to find an item or an IoT on the internet. Findability live will have something called WSD language. So this actually comes from service-oriented architecture. When two services want to talk to each other, in addition to knowing what they do, actually they need also a description. That means, suppose I am having a service which converts currency, I have to describe my service saying that you have to send me data in this particular format. This is how I will send my result back to you, and for this is what I charge. So in the cloud computing and even service-oriented architecture, experts have developed a language called WSDL, that is Web Services Description Language. Similarly, in the findability context of IoT, there is a language which is developed which will describe the device and its services and its description. This enables searching for these things through a search engines. So once, because the accessibility layer has given an unique URL for the device and findability has given a description, now once it is done, now using the same search engine, we can identify the items on the internet. That means if I have connected a sensor to the internet, the Google search engine can identify it because it has a unique URL and it can also describe itself. So the third stage is actually sharing. What it actually means is, see, suppose I have a sensor installed in my college or my field, and suppose somebody wants to access that, so my device must be in a position to share that information. For that, you need a kind of a common data format. That is what is using in pushing data. That means I will collect my data, exchange with the machine which is of choice. To make this sharing possible, I have to use some standard format. For example, we have a native format like data format like XML format, which is used among the cloud computing or web services to exchange data. So that is what the point is. When you are using a sharing layer, this is what happens. Once smart things are accessible and findable on the web, how do we share them? That means how does a particular IoT device in a fridge or in a car can share information with a manufacturer if that is possible only through a common data format. And the fourth one is called composition layer. Composition layer is now that I have found the information, how do I compose into services? That means, see, I have a Google map, I have a marketing information. Can I combine these two data into use it as a service? For example, many of the transportation companies today use Google Map to help people to navigate through their localities. Like how does it happen? They use Google Map, compose that into a service so that their customers can use that. So look at this. This is a composition layer. Composition layers will help you to develop an application or a service based on the information that you have collected from sharing the information among and across the IoT. So any question? The point is this: in order to build an architecture for the IoT, I will be using web as the basis, and I will be using the same standards of web. So I start with actually the accessibility requirement. That means I connect a device to IoT device to internet and make it accessible by giving an URL. So once URL is given, I will move to the next stage called findability, where if a device is existing which is connected to net, I can use a search engine to find it out. Then once I do that, then I can make these two devices to talk to each other by sharing. That is called shareability. And finally, once this shared data can actually be used for composing information or services. So any question at this point of time? Sridhar, any questions?
Any tools you can suggest which are available for handling big data on clouds?
Yes, sir, we'll tell you. I mean, I'll go further because there are certain applications which I'll show you. I will show you, sir. After this, I will show that one. Okay. And a very straight answer actually. So big data means it's a volume and all. I will just answer this question, sir. Okay, there are many tools available on the internet for actually managing this big data. See, for example, since big data is both heterogeneous in nature and big volume, we needed non-traditional approaches. So one of the very famous system that you have is called Hadoop. So Hadoop is actually a framework which will help you to manage this big data. So there are many resources available like Cloudera and all, which gives you a lot many tools for actually managing this data. So the answer is Hadoop is the tool that you can use for managing big data. So what's the next question, sir?
What are the simulation tools available to simulate IoT?
Okay, I'll tell you, sir. That also will come later. So there are many simulation tools. For example, after this actually I have some examples which will tell you that there are commercially and open source available which will help you to create those things. And if you remember actually in the first slide I told you companies like Amazon and all, they have, Amazon has something called Amazon Kinesis and Google has something called Pub and Sub system, and Azure has some network system that I will show you. They can be used to simulate these things. That means you can actually connect and simulate those environments. Any other questions, sir?
Is universal plug and play similar to IoT over web?
No, actually universal plug and play only ensures that actually you plug and start playing. For example, in a plug and play what it says is actually the moment you plug into a system it starts operating, but it doesn't say that whether this what you have plugged in is actually device can be accessed by some other part of the world or other services. So plug and play is actually the beginning point, and thereafter the other things would happen. For example, you can insert your pen drive to a machine and start playing a game. So what it actually is restricted only to your machine. But if that game or that plug-in drive actually connected to net so that I can access from elsewhere, see if I can find out what game you are playing and can I send you an upgrade of that game, then it becomes IoT. Until then actually it is very localized thing which is connected to your machine. Any other question?
Can NS3 tool be used to simulate IoT?
So see, actually, sir, network simulation tool actually simulates a network. Okay. So, but network is one of the part of an IoT. See, network in the context of IoT is used to connect devices and make them communicate. So, what NS3, NS devices, tool help you to create a kind of, to create a network and create those nodes and monitor the communication that's happening between them. Okay. So if those nodes are IoT items, then yes, it will help you to create them. So you think that every node that you have created is an IoT device, not a computer.
Yes, sir. Go
Anything
on,
else?
sir. No, sir.
Good. Okay. So now the tools which are available for creation of IoT, yes. See, IoT is actually in action. So one of the first example comes from called Energy Visible. This is an European project where actually sensors capable of monitoring and controlling the energy consumption of household appliances offer their functionality through a RESTful API. What actually they have built an entire town or a locality where every electrical appliance is actually is an IoT which is capable of actually connecting to net using an API. So since this API is connected, it can be actually monitored across the world. Okay, across the world. And this is what happens actually. So every device is connected. So anybody at the location can like what is the electrical consumption in that particular town, which device is using what, how much of current. Okay, this is possible because they are all API enabled. The second project is actually Nimbit is an open source data historian server that built on cloud computing architecture and provides connectivity between devices using data point. So if you have devices connected across your campus or where, so this Nimbit will help you. So for the question that the other person asked me, are there any tools which will help you to manage a big data? And this is the one he should use, Nimbit. And here is another company called Zybly, which is commercial web of data aggregator. So there was a question asked about, are there any tools to manage big data? And this is the one. So this application actually helps you to manage the big data collected using IoT devices. So on the left side, you see directory services. That means what are the services available for managing big data, and the data services kind of data that it can manage, and business services, the services built on that. And this actually is called everything is a platform for unconnected devices. Suppose you have a devices which are not connected, this will enable you to connect this to the IoT and help you to process that data. And this is another one which is wirelessly connected interactive project. For example, now you have Bluetooth technologies, and if you are using a kind of an IoT approach in your in your campus, this service will help you a lot. This is another company which is also developing IoT application. This also answer to that person who actually asked me that can I manage big data and develop application, and this is the one that he should be using. So the conclusion is this: like any other human-made system, IoT needs an architecture, because like internet or like our telephone communication or like our television, IoT is a global phenomenon. So when it becomes global, it needs a very systematic approach, and that systematic approach comes from developing an architecture. So Web of Things is a new architecture for IoT. So after studying different approaches, what people have decided that let us use internet as the, today's web as the basis, and an architecture which is built for the IoT based on this WOT. The web is actually WOT or Web of Technology. Web is used as the basis for these things. So this is the end of first session. The whole summary of this session, let me tell you. So this is an approach developing an infrastructure, architecture for IoT to happen. IoT is a global phenomenon, so we have to ensure that it happens smoothly. For that, we need an architecture. So after considering different approaches, we have ended up with saying that one of the best way to go ahead is to use the existing the internet or the web. So in order to make this disconnected, I should ensure that each device becomes programmable, API compatible, so that they can be connected and may talk to each other. And web has been using this, and they have developed 4 different layers, starting from accessibility layer to composition layer. In between there is findability layer, which can be helped using that. So this platform can be used to develop different applications. The example showed you that there are different people have used this structure for different applications. For example, in the Energy Visible, some town or a particular province in France actually use this to monitor all the electrical devices. And similarly, everything is another application which has done that. So now a question time, sir. Any questions? Any questions, sir?
UPnP is a web-based architecture to access, discover any device and use over web. It is not local in nature?
No, actually, see, the thing is, see, whenever the first rule in internet is in the web is actually to be accessible, it must have an URL, and URL must be published. See, how will actually Google will fund my college website? Because I have published. So if it is a local internal URL or a IP address, it will not find out. So that means the first and foremost rule either in the web or IoT is actually your device must have a unique URL and that must be published. If it is not published, then it is not accessible from outside. So device may be local, but if it has a URL, then if that URL is published, then it is findable from anywhere. Otherwise, it becomes a local. It is like intranet in an organization. Internet also has an IP address, but it is not accessible from the outside Google search engine kind of a thing because it is not published. Any other question?
No, sir. We'll just wait for 1 minute.
Okay, thank you then. Okay, so next session will actually be on will IoT is secure enough, because since IoT is a global phenomenon and devices talk to each other and all this share information, it is very pertinent question to ask whether the information shared among these devices is secure enough. Are you sure that the information is only going to the intended devices and all? That will be part of my future session. Okay. And if you want to have any questions or if you want to contact me sometime, this is my contact address. Thank you, everybody.
Thank you very much, sir.